Imagine you are selling products online using Stripe for payments. A customer visits your website, enter card details, make a payment. Now here is the question. How does your application knows that the payment was successful? Should your application keep asking Stripe every few seconds? Something like, is payment successful? Is payment successful? Is payment successful? That sounds wasteful and inefficient. There has to be a better way. What if Stripe could simply notify your application the moment payment succeeds? No repeated requests, no unnecessary polling, just one notification when something important happens. That idea is called Webhook. Today we will learn what webhooks are, why they exist, how they work, webhooks versus polling, real world examples, trade-offs, security considerations, and frequently asked interview questions. By the end of this lesson, you will understand why companies like Stripe, GitHub, PayPal, Shopify, Twilio, Slack heavily rely on webhooks. Before that, let's try to understand now what is the problem, how do systems notify each other. Imagine we are building an e-commerce application. A customer makes a payment using Stripe. Now our application needs to know, was the payment successful? Did it fail? Was it refunded? Was a chargeback created? The information exists inside Stripe, but our application needs that information too. How should Stripe communicate with us? The naive solution is polling. Many beginners think we will just keep asking Stripe. Our application keeps sending requests to Stripe. Has the payment completed? Has the payment completed? Has the payment completed? Most of the time, Stripe responds, no change, no change, no change. This creates a lot of unnecessary network traffic. And if we check too infrequently, users may experience delays. This is exactly the same problem we discussed with polling. Engineers needed a better solution. At some point, engineers asked, why should our application keep asking? Why not let Stripe notify us when something important happens? Instead of are we there yet? Are we there yet? Are we there yet? The external service could simply say, hey, the payment is succeeded. And that's exactly what Webhook does. Now let's try to understand what is a webhook exactly. A webhook is simply an HTTP callback. One system automatically sends an HTTP request to another system when a specific event occurs. Think of it as don't call me, I will call you. Instead of constantly checking for updates, you register a URL. When an event happens, the provider sends information to that URL. Let's try to understand the basic webhook architecture. Let's follow the flow. A customer makes a payment. Stripe processes the payment. Everything happens inside Stripe. Now imagine the payment succeeds. Stripe creates a payment successful event. Instead of waiting for our application to ask, Stripe immediately sends an HTTP request to our webhook URL. Our application receives the event, updates the order, sends an email, updates inventory and continues processing, and the communication is automatic, no polling required. Now let's try to understand how webhooks work step by step. Let's walk through the entire process. You create an endpoint, something like this, https myshop.com/webhook. You register this endpoint with Stripe. An event occur, example payment succeeded. Stripe creates an HTTP request. Next step is Stripe sends the request to your webhook's endpoint. Your application processes the event. Your application responds 200 OK, indicating the event was successfully processed. Real world example consider is of Stripe payment. Let's walk through the real scenario of payment at Stripe. A customer completes checkout. The Stripe processes the payment. The payment succeeds. Immediately Stripe generates a payment success event. Stripe sends the event to the order service through a webhook. The order service receives the notification, updates the order status, marks the order as paid and confirm the purchase. Notice that the order service didn't have to ask Stripe for updates. Stripe pushed the information automatically. Real world another example is of GitHub webhooks. Imagine you are using GitHub. Every time code is git push, something needs to happen. Maybe run tests, build application, deploy software. How does GitHub notify this system? Using webhook. A developer pushes code to GitHub. GitHub receives the push event. GitHub immediately triggers a webhook. The webhook sent an HTTP request to the CI/CD system. The CI/CD pipeline starts automatically. Build begins, test execute, deployment may start, all triggered by a single webhook. Similar real-world example is of Shopify. Suppose a customer places an order. When a customer creates an order, Shopify generates an order created event. Shopify sends a webhook notification to the warehouse system. The warehouse system immediately begins fulfillment. No polling, no manual synchronization. Everything happens automatically. Now let's try to understand the difference between webhook versus polling. This is one of the most common interview questions. Polling architecture is our app external services. With polling, our application already asks for updates. Most requests return no useful information. This wastes bandwidth and resources. In the case of webhook, the architecture will be like this. With webhook, the external service sends information only when something important happens. No unnecessary requests, no wasted traffic, just event-driven communication. Now, why companies love webhook? Imagine millions of payment events, millions of order events, millions of notifications sent. Polling every external service would be incredibly expensive. Webhook solves this elegantly. The provider only sends updates when something changes. This reduces network traffic, API calls, infrastructure costs, and latency. The hidden problem with webhook is, now you might think webhook sounds perfect. But remember, every solution creates new challenges. What happens if your server is down when Stripe sends the webhook? The event may be missed. What if the network fails? The event may not arrive. What if Stripe sends the same event twice? Your system may process it twice. These are real production challenges. Most providers solve this using retries. Let's follow the failure scenario. Stripe sends a webhook, but our server is down. The request fails. Instead of giving up, Stripe waits and retries later. Eventually, the server becomes available. The webhook is delivered successfully. This retry mechanism improves reliability. Another important concept is idempotency. Sometimes provider may send the same webhook more than once. Example, payment succeeded, arrives twice. If we are not careful, the customer may be charged twice or the order may be processed twice. To avoid this, webhook handlers should be idempotent, meaning processing the same event multiple times should produce the same results. Now let's try to understand the webhook security. Security is extremely important here. Imagine anyone on internet could send a fake webhooks. That would be dangerous. Most providers sign webhook request. Let's follow the request. Stripe sends a signed webhook. Our webhook endpoint receives it. Before processing the event, we verify the signature. If the signature is valid, we trust the request. If it is invalid, we reject it. This prevents attacker from sending fake events. Popular companies which uses webhooks are Stripe for payment events, GitHub, push events, pull requests, releases, Shopify, order events, inventory events, Twilio, SMS delivery events, call events, Slack, notification and integrations. Now let's try to understand some of the trade-offs. Advantages are its real-time updates, no polling required, efficient network usage, event-driven architecture, easy integration between systems, lower infrastructure costs, and some of the disadvantages are more complex error handling, retries required, duplicate events possible, security considerations, harder debugging, provider availability matters. Few very frequently asked questions are in the interviews are, what is webhook? How is webhook different from polling? Why are webhook more efficient than polling? What is idempotency in webhook? How do webhook handle failures? How do you secure webhooks? All these questions are very frequently asked, so prepare for it. Now let's try to understand some of the common beginner mistakes in this area. Mistake 1 is trusting every incoming webhook. Always verify signature. Mistake 2 is ignoring duplicate events. Duplicates happens frequently in this case. Mistake 3 is doing heavy processing inside the webhook handler. Better approach, receive event, store event, push to queue, process asynchronously. Mistake 4 is not handling retries. Retries are a normal part of webhook system. Now let's try to recap what all things we understood. A webhook is an HTTP callback. Instead of repeatedly asking for updates, system receives notification automatically when events occur. Providers push events, consumer receives them. Webhooks power integration between systems like Stripe, GitHub, Spotify, Slack, and Twilio. Interview one-liner is polling asked repeatedly. Webhooks notifies automatically, and that simple idea powers much of the modern event-driven internet.